Today's lesson is 3.3 CPCTC in circles. Before we get into CPCTC, we're going to start with the circle part. Um, for now on, we will probably see this often in proofs. Circle P, okay, that might be given in problems. So if this is given, what that means is you have a circle with the center of P, okay? Um, Hopefully you remember this from when you learned geometry in 8th grade. PW is called a radius. And there's a postulate we can get if we have this circle. So if this is given, we can say that all radii in a circle are congruent. All radii in circle are congruent. Okay, so if we have a picture like this, and we have a triangle formed here, okay, we know that these two, PS and PT, will be congruent because those are both radii. We can pull that from the diagram because this is given in our proof. Okay, a couple other things about circles. Circumference is 2 pi r, or you could also do pi times diameter. Pi is 3.14, but you can go ahead and use the pi button in your calculator. Area is pi r squared. Um, for circumference, we're just going to use units, but for area, we're going to use units squared. Okay, so don't forget about that. All right, on to CPCTC. CPCTC stands for corresponding parts of congruent triangles are congruent. So corresponding is our first word. Parts, for the second P, of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. So what we are doing here is once we prove the two triangles congruent to each other, we can now prove any parts of the triangle, such as angles or sides, are also going to be congruent. So this is very important. To prove parts of the triangle is congruent, first prove the triangle is congruent first. There's two firsts in there to stress the importance that it has to be proven first. Okay, so looking at example 1. I have circle D and I have angle 1 is congruent to angle 2. I want to prove NF is congruent to NH. But before I prove this, I have to prove the triangle is congruent. So a step before this one, and I should go backwards, would be triangle NFD is congruent to triangle NHD. Remember, order matters here. So N corresponds with N, F corresponds with the H, and then D is the same. Okay, so let's go ahead and start. Remember the ways I can prove triangles congruent. Side, 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 and angle, side, angle. So we have circle D. Circle D tells us that there's probably going to be radii in the picture. Okay, what are the radii? Well, I have FD coming from the center and DH coming from the center. So those are going to be my first sides, FD and DH. That is my first side of the triangle. I also have angle 1 congruent to angle 2, and that will be my angle. So I have side, angle. Now I'm looking for a third side, because side, angle, side is the only one that I have that will work on this list here. So can I pull anything from the diagram? Well, the triangle is sharing a side right here. It's sharing side ND. So I can say ND is congruent to itself. If you want, you can put diagram here. That is my last side. Now I can go ahead and group those three things and say the triangles are congruent. Triangle NFD is congruent to triangle NHD. So remember, the order matters on your second triangle. This one not so much, but as long as this one matches, you're okay. Once I have the two triangles congruent, I can now say that corresponding parts of congruent triangles are congruent. Now I can say that NF will be congruent to NH. Okay, so let's go ahead and list our reasons. 1, 2, 3, and 4. So reason 1, all radii are congruent. Okay, because they're given a circle, we can pull from the circle that the radii are congruent to each other. 2 is reflexive. When something equals itself, it is reflexive. And 3, side angle side. 4 is our new step. Once the triangles are congruent, we can say corresponding parts of congruent triangles are congruent. Any parts now are congruent. So now we have NF congruent to NH. Example 2. This one wants me to prove that AB is congruent to DC. Okay, so let's think about this. There's a lot of triangles in this picture. We can make it like this, or this one and this one, and this one and this one, but we want to prove this one is congruent to this one because these are the two pieces that they want us to prove. So going backwards, I want to try to prove triangle EBA is congruent to triangle EDC. Okay, so right now I have given that angle AEC. AEC, this big one, is congruent to angle BED, this one. Now that's not an angle inside the triangles that I want to prove. Again, I want to prove this one on the left and this one on the right. But if I subtract something out of it, if I take away this angle 2, I do have angle 1 and angle 3 left, which is key. I need that then for my first A. Go ahead and write down your first given. So I could subtract angle 2. In order to subtract something, I need to make sure I'm writing it down. So from the diagram, I can say angle 2 is congruent to itself. If I take out angle 2, I'm left with angle 1 congruent to angle 3. And that is an angle inside my triangle, so that's my first A. Moving on, I have EB. So EB is this side, congruent to EC, that is the side of the triangle that I want. So go ahead and write that down. Okay, so this is my next side. AS, looking for another angle. I have it right here. Angle 4 and angle 5, which is this one here. So go ahead and say angle 4 is congruent to angle 5. That's given. And that's my angle. So I have ASA. I can go ahead and group those three. And say now triangle EBA is congruent to EBA. So I need ECD. This is a mistake. It should have been ECD. Okay, remember order matters here. And that, coming from that, I can now say that AB is congruent to DC. Okay, so my reasons. Here's 1, 2, 3, and 4. So my first reason, how do I know that something's equal to itself? That is reflexive. 2, how do I get from a big angle to a smaller one? Well, I'm subtracting, so using subtraction. 3 is angle side angle. And 4, once I have the two triangles congruent to each other, I can now say corresponding parts of congruent triangles are congruent. And I'm done. All right, last proof. They are given us that DE is perpendicular to AC, so go ahead and write down your given. Okay, remember perpendicular means that they're going to be right angles here. Okay, that's not really going to quite help us because the right angles are not parts of the triangle. That's a piece of the triangle, same with this one. So let's just mention it. Angle DBA is a right angle, and same with angle CBE. Okay, if they're both right angles, I can say they're congruent. Angle DBA is congruent to angle CBE. Again, though, CBE and DBA, those are not parts of the triangle. but I do have angle 2 is congruent to angle 3, so if I subtract 2 and 3, I'm left with 1 and 4, which are parts of the triangle. That would be my first A. So right underneath, I'm going to subtract angle 2 and angle 3. This is given. If I subtract the 2, I'm left with angle 1 is congruent to angle 4, and that would be my first A for the two triangles congruent. Okay, they also are giving me AB, so I'm done with this one, done with this one. I have AB is congruent to BE, AB and BE, so I can go ahead and write that down. Okay, AB and BE, that's my side. Okay, and then the last one, they're giving me an angle here, angle A and angle E. Okay, angle A and E are going to be my third angle, and I have angle side angle. I can now see the two triangles are congruent. Okay, careful with your order, writing your order here. If I say GAB is going to be congruent to triangle F would be our first letter. A matches with the E, so E is next. And then B is matched up right here. So FEB. Okay, I'm not done. I haven't gotten to what I want to prove yet. Once I have the triangles congruent, I'm going to go ahead, do a continuation. So again, they're trying to prove FE is congruent to GA. And now I'm done because I'm done with the last step, which is the proof step. Go ahead and number them. So this is the same reason. I'm going to put 1 twice. We have 2, 3, a 4, and last one is 5. Okay, going through my reasons. How do I know that perpendicular makes right angles? Because I know the definition of a perpendicular line. Perpendicular lines. Step 2, how do I go from right angles to them being congruent? It's not definition of right angle, it's all right angles congruent. So 2 is all right angles are congruent. Number 3, we're going from a big angle and we're going to a small angle, so what we're doing is subtraction. 4 is angle side angle, proving the triangle is congruent. And 5, corresponding parts of congruent triangles are congruent. That's it for today.